everybody. Today we're going to be talking about our similarity proofs. So we're trying to prove that two triangles are similar to each other. And the way we're going to do that is by talking about the angles. And remember that we know there's 180 degrees in a triangle. So if two triangles have two angles that are equal, we know that the third angle has to be equal. So we know that two triangles are similar if two things happen. Okay, so if and only if the corresponding angles are congruent, and if the corresponding angles are congruent, then we'll know that the corresponding sides are in proportion. So we'll know this both ways. If the sides are in proportion, then the angles are going to be equal. So we are calling this the similarity postulate. So we're going to call this right here our angle-angle theorem. Okay? So if we want to prove two triangles are similar, notice our symbol here, we want to show that two pairs of corresponding angles are congruent. All right, so let's take a look at number one. They tell us that angle A and angle D are congruent. Tells us angle B and angle E are congruent. And my goal then is to show that AB over DE is the same as AC over DF. So I'm trying to show that we have a proportion. All right, so since we already have those corresponding angles equal, we now know that triangle ABC is similar to triangle DEF. So number two, right, our reason for that is our angle-angle theorem. Now, since my triangles are similar, I know that my corresponding sides are forming a proportion. So my reason for step 3 is that the corresponding sides of similar triangles are in proportion. That's the end of my proof. I'm all set. So let's take a look at number 2. In number 2, it tells me that AB is perpendicular to AC, AC is perpendicular to CD. So there's one set of angles that I know are congruent. And if I take a look right here, my favorite kind of angles, my vertical angles, are also going to be congruent. So what I'm looking at is this is a proportion I've already cross multiplied. So I know that AB perpendicular to AC. I know that AC perpendicular to CD, because that is all given to me. So now what I can say is that I know that angle A and angle C are indeed right angles. And I know that because perpendicular lines form right angles. Since they're both right angles, I now know that angle A is congruent to angle C because all right angles are congruent. So now that I have that piece of information. All right, so now I have one set of angles. Now I'm going to say that angle 1 congruent to angle 2, and that's because I know my vertical angles are congruent. So now that I have two sets of angles equal, I'm going to say that my triangle BAX is similar, almost wrote congruent there, similar to triangle DCX, making sure my letters correspond, and that's my angle-angle theorem. Now that my triangles are similar to each other, I take a look at the sides that they're giving me. So I have AB and I have CX. They don't correspond to each other. I then have my CD and my AX. So what I need to do is I need to form a proportion. So remember, there's lots of different ways that I can form proportions. One way is I can take that one side over there, and that's going to correspond to CD. So notice the side touching the right angle, side touching the right angle. That's equal then to the one that's touching the vertical angles, AX and CX. So the reason I know I can do this is because the corresponding sides of similar triangles form a proportion. Now, when we talked about these last class, we talked about, all right, well, how do we solve those if they had a variable in there? Well, we cross multiply. So we have AB times CX, which is equal to CD times AX. Now, it would be nice to say that we cross multiply, but unfortunately, I can't just use that verbiage. So a new thing that we're going to write now, so another way to say cross multiply, we're going to say that the product of the means equals the product of the extremes. And that's it. New fancy way to say cross multiply. So taking a look at the bottom part, I want to know, how do I then prove that these triangles are congruent by using transformations? So there's a couple of different ways that we can do this. Okay, so one possible way we can do this is using two transformations. So the first thing that we could do is we could dilate our smaller triangle, our triangle CXD, by the scale factor K equals. Now I can pick any corresponding sides that I want to. Now I'm going to pick AX over CX, and then we're going to call it C prime, X prime, D prime. And the reason we're going to do this, so K is really equal, no, I'm sorry, K scale factor times CX equals AX. This way I know that C prime X prime is equal to AX. Okay, I know those lengths are going to be equal. Now, what we're going to do next is we are then going to rotate our new triangle, C prime, X prime, D prime, 180 degrees about X, so that X prime maps to X, C prime maps to A, and D prime maps to B. Now, we know that we can do this because dilations and rotations preserve our angle measures. Now, as long as we preserve our angle measures, okay, I'll now know that my triangle C prime, X prime, D prime was congruent to triangle AXB, and my triangle CXD, similar to my triangle C prime, X prime, D prime. So now we know that triangle AXB is similar to triangle CXD. So in the very beginning, we knew we couldn't prove these congruent. We had to prove them similar.